Should I be seeing something?
You absolutely should. And it's my first lesson of the day, so I sometimes didn't get all the buttons pushed. Okay, are you seeing my screen now?
Yeah, perfect. Thank you.
Okay, so what I meant is you have to bring this 2 up as a negative exponent. So the derivative here is the power rule
Okay.
followed by the chain rule. Do you know what I mean by that, or is any of that unclear?
Isn't it like you have to?
So we're gonna bring this -2 down.
Yeah.
Okay, so it's -2 times 7. So it's -2 times 7, x squared plus x plus 1. You subtract 1 from that exponent. Okay.
Okay.
And then you multiply by the derivative of this. What's the derivative of the inside part?
2x plus 1.
Yes. Now, WebAssign doesn't require you to simplify, but I'll just do a little bit of this here. This becomes -3, so it's going to be on the bottom. X squared plus x plus 1 to the -3 power. -14, 2x plus 1, like that. And that's your derivative here. That's what goes in the box.
Okay, so that's it?
That's it. But it's critical that you rewrite it.
Okay.
All right, so let me move to the next question here. That's an implicit derivative. I think I saw number 1. Let me do that one first. Number 1 is a little bit easier than the one we just did because it's a less complicated function. Okay. All right, so calculate derivative of the function here. This is the same thing. It's power rule followed by chain rule because the exponent is what you're taking the derivative of first. So you have 0.5. You bring that exponent out in front. 2x plus 4. You subtract 1 from the exponent, and then you multiply by the derivative of the inside function. So the inside function is 2x plus 4. Its derivative is just 2. These multiply together to make 1. So you don't write anything, and that's 2x plus 4 to the minus 0.5 power. That's what goes up there for the answer. All right, so I am going to try and do these in order because I do think that will be best here for understanding. Do you have an exam coming up in this class?
Yeah, tomorrow.
Okay. Oh, you said that already. I apologize.
You're good.
Do you know if it's going to be like these questions?
I think so.
Okay. A lot of times they just grab them from the exam review or the homeworks if it's through WebAssign. They don't make much difference. All right, so the derivative here, you have to be able to take the derivative of the ln function. If y equals the natural log of x, the derivative is 1 over x, but it's more generally 1 over whatever's inside here. So the derivative here is 1 over x squared plus 2. These absolute values, just ignore them. They're not important. They don't mean anything here. You then have to take the derivative of the inside function. The inside function derivative is 2x. So that simplifies to 2x over x squared plus 2. That all goes in there.
Okay.
All right, so I'm up to 13. Yeah, 13. Okay, so if y equals e to the x, the derivative is itself, okay? Sometimes it's written though like this e to the u, and the derivative is e to the u times u prime. So you keep this, when you take the derivative, you keep the exponent there, which is this thing right here, but then you multiply by the derivative of this. So
Okay.
I'm going to just rewrite this slightly. 2x squared minus 9x plus 5x to the minus 1. You're just taking the derivative using power rules. That's 4x minus 9 minus 5x to the minus 2.
Okay.
And that I mean, if you can get this all into there, the box, it should accept that as an answer. There's nothing really to simplify for that.
Okay. Let me
All right, so we're up to 16 now. 16. 16 is the implicit derivative. This is the first one of these that we've encountered. So this is very different than anything we've done up until now. The difference is that you're seeing both x's and y's.
Okay.
So the derivative of x is exactly the same. It's exactly the same. There's no different. But when you take a derivative of y, you can either write dy dx, which is probably what they're showing you in class, or y prime. Y prime is just a shorthand notation for that.
Okay.
So when we look at this first thing, x squared times y, these are two things multiplying each other. So that's product rule.
Yeah.
Product rule. So the derivative of the first is 2x. Keep the second. Plus, keep the first. What's the derivative of y? Well, if you treat it like x, it would just be 1. But whenever you take a derivative of y, there's always this dy dx. So the
Okay.
derivative of y here is really 1 dy dx. Now you don't have to write the 1, but I'm just doing it to show you that that's that 1 coming out in front there.
Okay.
Minus y squared equals 6. So what would the derivative of this be if it was x?
Is it? Oh, it would be 2x.
It'd be 2y, right? Because there's an x instead of y, but 2x, 2y. But then the derivative of y itself is dy dx.
Okay.
So the thing here is that whenever you take a derivative with respect to y, you always have to put a dy dx next to it. And the derivative of 6 is 0. So this is like step 1. Step 2 is to isolate dy dx.
Okay.
So let me just clean this up a little bit. This is 2xy plus x squared dy dx minus 2y dy dx equals 0. So to isolate this, these right here, you have to first move this to the other side. Okay, and then you have to factor out. You're going to factor out dy dx.
Okay.
So it's dy dx x squared minus 2y equals minus 2xy. And then you can solve for dy dx by dividing both sides by this. Okay. So this is your solution. This is your final answer. So I want to point out, though, maybe I'll send these notes out, but the calculus is done. This is the calculus step. Everything from
Okay.
here down is just algebra or rearranging terms. Like everything down is algebra. So the hard part is just being able to manipulate these letters and variables.
Yeah. Okay.
Okay, so that was 16. 18 is different. 24, 7, 35 is different. Okay. I'll just go to 18 now. All right, 18 says if $20,000 is invested in a savings account offering a 3.5% per year compounded continuously, that's very important. That tells us what equation is. It's A equals PE to the RT. They want to know how fast is the balance growing. That's the derivative.
Okay.
So we don't want to take the derivative until we put the numbers in. This P is 20,000. That's what you're starting with. That's your R, but you have to convert it to a decimal.
Okay.
Okay, so we got to put these numbers into the equation. A equals 20,000 e to the 0.035 t. And now I have to take a derivative of this. So do you remember from earlier what the derivative of e is?
It's just e to itself times.
It's just whatever it is. And then you have to take the derivative of this, which is
Yeah.
0.035. Okay, so now this is correct, but it's asking for a number. Well, that's where this 4 comes in.
Okay.
So it's 20,000 e to the 0.035 times 4 times 0.035. And sorry, my screen stopped sharing. I'm gonna grab my calculator and see if I get a number for that. All right, so it looks like it's 773.62. I assume you're checking these along the way. Let me know if there's ever an error. And
Okay. That one said it's 805.19.
is the correct answer?
Yeah.
Oh, I'm sorry. I put the wrong one into the calculator. So I'm sorry. Yeah, that is the correct answer is 805.19.
Okay.
If you got a calculator, it's always good to check me.
Yeah.
All right. Up to 24. Do you already have this question up on your screen?
24.
Yeah, like can I just draw the picture or do you want me to snip in the
Yeah, I can see it.
Okay, so there's a rectangular orchid that butts up to the house. So there's a house here. Right now, this isn't really a side. This is the house. The fencing for the southern boundary is $40 per foot, and for the east and west sides is $20 per foot. And the person has a budget. Their budget is $240, and they want to maximize the area, max area. Okay, so the area function is x times y. And I'm going to call this x and this y and this y. That's just my choice, but x is usually to the right and y is usually up. So the budget, the $240, that has to cover 1, 2, 3 sides. It has to cover the 20y plus the 40x plus the 20y. So 240 equals 40x plus 40y, and we want to solve for y because we're going to take that and put it into this other equation here.
Okay.
So you can actually divide everything by 40 here. So 6 equals x plus y. So y equals 6 minus x. So a equals x times 6 minus x. So that's 6x minus x squared. And then we have to take a derivative of that. So the derivative of that is 6 minus 2x. You set that equal to 0. X equals 3. Okay, so but that's the answer to our problem. We have to figure out what values go into the. We can go into the. I'm going to snip the question here so we can get the right numbers in here.
Okay.
So So the value of x here is this along here, like this. This is x equals 3 feet or whatever, 3 feet. The y value is 6 minus x. So it looks like it's also 3. So it looks like, and maybe you only get one chance left on these. I don't. That's why I'm.
It's not for a grade. It's just for review.
Okay. So you have 3 and 3, and then the area you get from putting them numbers back into the original. So x times 6 minus, well, it's x times y. Which is 9.
Okay. Okay.
All right, that takes care of that one. And then 35 here. Okay, yep, this is the classic problem you see on exams. Shows up every.
What number? 35?
Yeah, that's the last one that I see. Let me know if I missed any.
Okay, yeah, I can always send more if we have time. If you know.
The radius is growing at a rate of 5 centimeters per second. So that's r prime. R prime is 5. The rate of change is r derivative here. It says how fast is its area growing? That's a prime. That's what they want there. When the radius equals 10. So the area of a circle is pi r squared. And this is like how do I say this? This is like the implicit derivatives, where when you take a derivative with respect to a, that's a prime, and when you take a derivative with respect to r, 2 pi r, that's power rule. There's an r prime there. Hopefully you've seen that from class. Not sure. I mean, if this is unclear, let me know, because this is the key step here.
What is the r prime for?
When you take a derivative with respect to r, you get r prime. So it's power rule 2 pi r. That's how this first part is.
Oh, okay.
And over here, it's not 1. It's not, derivative a is not 1. It's a prime, because that's the thing you're trying to find.
Okay. Okay.
So now you just substitute the numbers in. You say, okay, well, I got 2 pi. What's my radius? Oh, it's 10. What's my r prime? Oh, that's 5. So that's 100 pi is your answer. Here. Okay, now it says how fast is the area growing at the instant? So that's, again, area growing is a prime at the instant when it equals 9 square centimeters. So you're saying, hey, the area is 9. The area is 9. Okay, so the area is pi r squared. And that's 9 equals pi r squared. So you divide by pi, and then you take a square root. So radius is 9 over pi. Now the a prime formula is the same as over here. A prime, we just grabbed that from over on the side. It's 2 pi r prime, 2 pi square root 9 over pi, and then r prime is still 5, because that's given in the problem.
Okay.
I snipped the part where it says whether to round or not.
Let me see.
Yeah, it does say to round your answer. So let me.
Integer.
It's easy to not get this into the calculator correctly. I've already made that mistake. All right, so I get about 53.
Okay. Should I send more?
It's up to you. Yeah. I think we got through all of those. Is that right?
Yeah.
Okay. Yeah. I mean, it's up to you. We got some time left over, so we can keep going.
Okay, I'll send some.
I can also make some problems up like these if you want as well. That's another option here for us.
There's a few more things that are like different on the review, so I'll just send those and then
Okay, great.
see. Okay, I just sent over 4 more.
Okay. Checking that for that email. There they are. All right. Okay. So have we done price elasticity of demand together?
I think so. I think so.
It's a lot. It's a lot. It's a lot of work. There's a lot of explanation as well. So I just wanted. So I was just asking here. So got your first picture 39. I think that's first. Let me just check 39, 41. Oh, 27, 20. Okay. Let me go back and do these in order. All right, so this is to find the location of all the relative and absolute extrema of the function. The first thing you want to do is always evaluate at the endpoints. We want to get those. We want to get those numbers there. So that's just a matter of getting that into the calculator, which I think you said you do have access to when you're doing the exam.
Yeah.
So I'm going to do that now. -2. So that's -4. Oops. That's 28. Okay. So next thing you do is you take a derivative of the original function. So the derivative g prime of x is 24x squared minus 24, and you set that equal to 0.
Okay.
So just factor 24 out, and then this factors into x minus 1, x plus 1. So that's x. Oops. That's x equal to 1, x equal to -1.
Okay.
Okay. Now what's great about this is these are already within the endpoints here. So it's from -2 to 2.
Yeah.
You have to check that your results are in that window, and these are okay. So now you find g of 1 and g of -1. So that's g of 1 is -4, and that's 28. Is that really right? Okay. So what I like to do then is to make a little picture based on this. It isn't real accurate, but at -2, it's -4. At -1, it's 28. At 1, it's -4. And then at 1, oops. Oh, I'm sorry. At 2, it's 28. So it looks like the function comes up, comes down, and comes up.
Okay.
So this is at -2. This is at -1. And then this is at 1. And this is at 2. So that helps us figure out what to put into these numbers. So the -2, -4 goes here. And I think it tells you in the instructions like put them in increasing order of x. So then it's minus 128, 1 minus 4, 228. And then looking at the picture here, these are both mins and these are both maxes. And this is where I'm not sure what the options are on the drop down. It's usually like absolute min, absolute max, relative min, relative max.
Yeah.
So the first one here is a relative min because it's lower than everything around it. It's not the absolute min because it's not lower than like this over here.
Yeah. Okay.
This is a relative max because it's higher than everything else, but it's not higher than, for example, that. This is the same thing, relative min and a relative max.
It said that they're absolute minimum and maximum.
There's none?
It says that it's an absolute minimum and then an absolute maximum and then an absolute minimum and an absolute maximum.
Okay, well, maybe just check on that with the instructor. Because the thing that I'm giving you is a more broader answer than the one that your instructor wants. The best example would be like if you had something like this. So like this is clearly an absolute max,
Okay.
and
Yeah.
this is clearly an absolute min.
Okay.
And this is a relative max, relative max, relative min, relative min. The issue is what happens when they're overlapping. And maybe you just have to remember for the test that it's an absolute max.
Okay. Okay.
All right, so the worldwide annual sales of a product were projected to be approximately, and this is Q here, and a price P, and they want to know about revenue. So revenue is price times quantity. The price is P and the quantity is minus 10P plus 4720. So that's minus 10P squared plus 4720P. So to figure out where the largest revenue is, you have to take R prime.
Okay.
So R prime here is minus 20P plus 4720. And you set that equal to 0 and you solve for P. And that ends up being at 236. So I believe that's what it's looking for in part A there. That's the price for the annual projected revenue. So then you can put this number back into here and here for P, or even this line,
Yeah.
and that's how you get your revenue function or your revenue value. All right, so I get, it's a pretty large number here. R of 236 is 556,960.
Okay.
All right, okay, if we move on to the next one here, 39.
Yeah, perfect.
Okay, so the this one is a kind of extension of the last problem. They want the price elasticity of demand. That is minus P over Q times dQ dP. So it's really three things. You got to get P, which is given. They tell you that P is 31. Q you get from this right here. So we know that P is 31. Q is equal to 1116 minus 18 times 31. We'll get that number. And then we have to take the derivative of this. dQ dP is minus 18.
Okay.
So let's get these numbers and then we'll put them into the formula to get, so P is 31, Q is all right, so this Q is 558. And then so we're just putting those numbers in this formula. So it's minus 31 over 558 times minus 18. Oh, wow, that equals 1. That's shocking. It's usually not 1 in these questions.
Okay.
Because that's unit elasticity. That's where it's neither elastic or inelastic.
Yeah.
And it also gives the answer to these other ones because that like really shocked. Okay, because this first box probably says up or down.
Yeah.
And it's not going up or down. Can you check the answers?
Yeah.
I don't.
It's going down
By 1%.
by.
See, these always match.
Yeah, it's going down by 1%.
Okay. All right. Great. So normally this number is like 1.2 or 0.8. It's not 1. It's not 1 because when it's 1, that price is the one that works. But let's do it as if we didn't know that. So revenue is price times quantity, and your price is P. Your quantity is 1116 minus 18P. So that's 1116P minus 18P squared, 1116 minus 36P.
Okay.
So we're going to set this equal to 0. 1116 divided by 36 is, I got too many ones, is P equals 31. And that's because, and again, this is just, it's a function of this question where they gave you an answer that they weren't supposed to. Wherever elasticity of demand equals 1, that's where the maximum revenue is at that price.
Okay.
And so that's why it's 31. The revenue is price times quantity, or it's this function. So the revenue at a price of 31 is 1116 times 31 minus 18 times 31 squared. Let's get that number for you. All right, so that's 17,298. All right.
Perfect.
Okay, so we got one more question. Okay, let me snip this in, and then we'll. Okay, so what is the corresponding to figure that out. Okay, so we have to find E again. So P is 28,000, 2,800, sorry. And Q is from here. So Q is 10,000 minus 2 times 2,800. And then our dq dp is the derivative of this up here, which is minus 2. So let's get this number, 5,600. Looks like it's 4,400. All right. So the E is the minus P over Q times dq dp, and that's the minus 2,800 over 4,400 times minus 2. So this time it does not give us a, like a really nice number. It's a decimal. So I ended up getting 1.27 for that.
Okay.
And then because it's greater than 1, if E is greater than 1 and if E is less than 1, there's one of these words goes along with it. Can't remember which one though. So let me look that up. I should know. I just don't do this in a way where.
Isn't it elastic if it's greater than 1?
Okay. Okay, so this is inelastic, and this is elastic. So in your case, it looks like it is elastic.
Okay.
So this is where it's a little bit weird. If it's elastic, the price needs to decrease. And see, this is where I always kind of like draw like this curve. Like this is where E equals 1. So if you're over here, your price has to go back, meaning decrease. If you're over here, like if it's less than 1, you have to increase your price. So if it's inelastic, you increase your price. So in this case, they should charge less.
Okay.
Part B is exactly like what we've been doing. You have to find revenue. Revenue is price times quantity. It's price times 10,000 minus 2p. That's 10,000 p minus 2p squared. And then you have to take a derivative of that. The derivative is power rule 10,000 minus 4p. You set that equal to 0 and you solve for p. P ends up being 2,500. $2,500 is what they should charge. And then the revenue you get from this line right here, revenue of 2,500. And see how that's consistent with our previous answer? They were charging 2,800 and we said, oh, it's elastic, which means they should decrease the price. Well, 2,500 is less than 2,800. So it kind of works together.
Okay.
So let me get the revenue here. The revenue is, oops, I didn't write this correctly. It's 10,000 times 2,500 minus 2 times 2,500 squared. It's a big number here. I'm getting to it here. 10,000 times p minus 2 times p squared. Okay, so it's 1,250,000, 0,000. Okay, there. So it's 12,500,000. That's the max revenue.
Okay, perfect.
You feel like this will help you get towards your work towards your test?
Yeah, I think so. That actually helps a lot.
There's a lot here, but you can do this. It's all similar to what's on these notes.
Yeah.
Does this cover everything you wanted to work on today?
Yeah, I think I'm good. Thank you.
Great. I'll send out the notes and screen recording here shortly, and I'll see you next time. Thanks again for scheduling.
All right. Thank you. Bye.
Bye.